Bismillahirrahmanirrahim. How are you, dear students? I hope that all of you are doing fine and staying safe. Up till now, we have studied different aspects of an operating system. Previously, we studied memory management, and today we are going to learn about the translation softwares, mainly compiler. In your early introduction to computer sciences in your junior classes, you might have heard that computer can only process binary. And all the programming that we do is usually in some high level languages because we humans cannot work in binary. So those high level language program code has to be translated into binary using some language translation softwares. Those language translation softwares actually varies from language to language. For example, the language translator software that was included in assembly language was called assembler. There are some language which are based on a language translation software called interpreter. And there are some languages like C language which are based on a language translation software called a compiler. The primary goal of these language translation softwares is to translate the high-level language program code into machine code, the binary. Today we are going to have some introduction and learn about some of the programs that are used, that are working in coordination with the language translation software. And in tomorrow's lecture, we are going to look into the language translation process, the compilation process in detail. So what's actually a compiler? Compiler actually takes the source code and translates that into the machine code. Compiler itself is quite a complex program. The compiler itself is about 10,000 to a million lines of program code which work together to make the compiler. The source code is actually written in some high-level language. For example, if you're using the C++ or VB.NET, the code that you are writing would be the source code, and the compiler is going to translate that into the object code, which is labeled target program here. The compiler will translate your program and create an executable file for you. That executable file can be run as many times as you want. The benefit of using a compiler is that your program will not have to be translated again and again. Once you have translated the program and made the executable file, then you just need to run that executable file. You don't have to go through the translation process again and again. Writing machine language numeric codes can be a lot time consuming and a lot confusing as well. You might remember from your O levels, you performed an activity of converting your own names and website URLs into ASCII codes and then converting those ASCII codes into binary. Now, imagining that a person has a 4-letter name, that 4-letter names and each letter is represented in 8-bit ASCII, the 4-letter will be represented in 32 bits of binary. Imagine having to write every character in binary. So your time will be consumed and the chances of error will be much high, and there will be a lot of difficulty in writing the code, and there will be only a few people able to program in this way. There will only be a few people which are able to program directly in binary. Then we developed the assembly language on top of binary. You might remember the assembly language from your AS. An assembly language used mnemonics. The mnemonics were the short operation codes which can be used as command to implement any operation, any command procedure. But again, it's difficult to remember the mnemonics and their purposes as compared to understanding the plain English-like sentences. So since assembly language was developed, but it was still much difficult to learn and read and write, we developed the high-level languages like you have practiced on VB.NET. In that language, you have seen that the statements that you write are actually quite easily understandable because they are similar to the language we speak and use in our daily life. This is where the compiler is needed, translating that high-level language code to the binary of computer science. The first compiler was developed between 1954 and 57. There was a language called Formula Translation, abbreviated as FORTRAN, and the first compiler was developed for that language. The structure of natural language was studied at the same time, but FORTRAN was the first language to incorporate a compiler as a language translator. Now there are several other programs that work together with a compiler. For example, as I was telling you, there is another language translator called interpreter. Language like BASIC and LISP. LISP was a list processing language which was used for artificial intelligence programming. They used interpreter. What the interpreter used to do is it reads the program line, decides what that line means, and executes that line right then and there. Then it goes to the next line, reads it, checks it for error, decides its meanings, and run that line. So interpreter actually runs the program line by line. So if you have to run a program line multiple times, that program line will be read and assessed and translated again and again. So interpreters are comparatively slower than the compilers. But the process of scanning the line, checking the syntax, translating that into binary, these things are actually similar between interpreter and the compilers. The main difference is where compiler actually executes the program as a whole in the form of an executable file, and interpreter executes a program one line at a time. Then, as I was telling you about assembler, the language translator package that came with the assembly language. Assembly language used mnemonics, and mnemonics had their own binary with them. So assembler actually used those mnemonics, translated them into the machine code, and then run the program on a specific microprocessor. The machine-oriented programming, like the writing the drivers of hardware devices for different microprocessors and operating system, that sort of thing is done using the assembly language. Then you have another specific software called linkers. Your executable file might have different files, different libraries, different functions associated with them. You might have used some built-in functions, built-in function libraries to write a complex and complicated code. The linker actually combines all those files that you have used, all those functions that you have used, and combine them into the executable file. All the files that your program needs to create and run, linker is responsible for linking all those files to your program. Remember, there was a file called DLL file, Dynamic Link Library. Linker is responsible for creating that file and using that file. It is also responsible for linking all the files and the library functions that you have used in your program. Then we have another program that works with your compiler called a loader. When a program has to be loaded into the RAM, it has to be allocated some storage space inside RAM where it can create its variables, where it can create load its files. So each program requires a certain amount of space inside RAM. We have discussed that in great detail when we talked about the memory management. So loaders actually are responsible of resolving all the addresses starting from the base address, starting from the first instruction of the program. Inside that data structure that is created in the main memory by the operating system specifically to run the program. And if you want to oversimplify, you can just say that loader is responsible for loading the program's variables and files into the main memory. Then we have preprocessors. Before a program's execution can be started, there is some functions which are, there is some tasks which are to be performed. For example, if you are adding comments in your program code, and adding comments in the program code actually doesn't do anything good for the processor. Comments are non-executable instructions. They're only for there for us, so we can understand why we wrote a specific program or subroutine. They serve as little notes for the programmers. So when a program has to be executed, the comments actually are deleted. Then you might have included some library files. You are writing a specific mathematical function like maybe square root function that which is built in into the maths function library of your programming language. You have to import that library first and then use the function. So things like that are called preprocessors. So preprocessors actually work with the compiler for the execution of the program. They prepare the program for the processing. In a programming language, we have something called interactive development environment or IDE. Each programming language has its own IDE. In our last chapter of paper 2, we studied the different features of IDE as well. So one of the main functions of an IDE is to let us edit the program, write a new program or edit an old one, modify an old one, add new programming statements to an existing program, or make changes to our program. All that falls in the editing. So editors are there to help us actually write the program code. Then obviously, one of the most important things are debuggers. And as you have written your own program codes, you know that very well. Whenever you hit the run key, whenever you hit the compile button, you can see that there is, most of the time, there is some error, some syntax error or some logical error causing your program to malfunction. So a debugger is that part of program which actually tells you that where is the program error. Debugger actually responsible for telling you that there is a program in some line number 11, and then you go to that line and correct your program. Also, it sometimes gives you the hints about the possible solution to that bug, that program error, which is there in your program. And also there are some tricks to it as well. Remember, we did the variable lookup tool to pinpoint and locate the errors. We can add the breakpoints to halt the program execution and see which of the program subroutines are causing the error. So basically, debuggers are there to find the errors in a program and help us debug that error, remove that error. This is where I'm going to take a pause, and I would like you to research on all those programs that we have studied in addition with the compiler, the linkers, the loaders, the debuggers, the editors, and build a strong concept for yourself that how these programs, what is the purpose of these programs, and how they are facilitating our language translation process. In the second part of this lecture tomorrow, we would discuss how the translation is actually done. So see you then. Moving on to the question answer session now. Thank you very much. Allah Hafiz.